Welcome to this explainer. You know the drill. You scrape your knee, get a splinter, or catch a bug, and boom, it's red, it's swollen, it's hot. We usually think of inflammation as just this pesky annoyance we want to pop a pill to get rid of, right? But today, we're totally reframing that. Inflammation isn't just a symptom, it is actually a brilliantly engineered, heavily coordinated emergency response system. Think of it like a microscopic war being waged right under your skin. Without it, literally even the smallest cut could take you out.
So here is our mission briefing for today. We're going to track the emergency alarm, see how the body clears the vascular highways, watch the first responders arrive and neutralize the threat, compare acute versus chronic battles, and finally, look at resolution and rebuilding.
Section 1. The body's emergency alarm. Let's start right at the beginning, where the neighborhood watch spots a breach.
To handle these breaches, the entire inflammatory response follows a really strict protocol known as the 5 Rs. This is basically our roadmap. First up is recognition of the invader. Then, recruitment of our cellular troops. Next, removal of the agent, followed by regulation to make sure the response doesn't go totally overboard. And finally, resolution, where the whole area is repaired. Now, think of cells like macrophages and mast cells stationed in your tissues as dedicated security guards. They're constantly on patrol. The absolute second they spot an invader, like those microbes entering the tissue, they recognize the threat and fire off chemical flares like histamine and cytokines. These chemicals act exactly like a blaring siren screaming for immediate backup from the bloodstream. Section 2, clearing the vascular highways. Because, you can't get fire trucks to a fire if the roads are too narrow. To solve this massive logistical problem, your blood vessels physically change. Look at the normal vessel on the left. The cells lining the wall are packed super tight. But when those chemical flares go off, two crazy things happen. First, vasodilation. The blood vessels literally widen, turning a tiny one-lane road into a massive 4-lane highway to pump in more blood. Second, endothelial retraction. As you can see on the right, the cells lining the vessel physically pull apart. They're basically opening the barricades, creating gaps so emergency fluids and proteins can rush directly into the damaged tissue. So the big takeaway here is that this microscopic widening and fluid leakage, that is exactly why your scraped knee feels hot, looks red, and gets all puffy. Clinically, we call that swelling, edema. And it's not just random fluid pooling up. The body is intentionally opening the floodgates so a surge of protein-rich plasma can wash into the battle zone, dilute any toxins, and set the stage for the heavy hitters to arrive. Section 3. First responders arrive. The roads are clear, the barricades are open, so it's time for the cellular SWAT team to hit the scene. Getting these white blood cells out of the rushing bloodstream and into the tissue is a highly orchestrated event. Think of a leukocyte like a speeding car on the highway that needs to hit a very specific exit. First, they move out of the fast lane and over to the side. We call that margination. Then, they hit chemical speed bumps that slow them down into this tumbling motion, which is rolling. Next, they slam on the brakes completely and stick to the wall, adhesion. And finally, they physically squeeze through that tiny alleyway between cells to get into the tissue, a move called transmigration. You can really see that journey happening here. In this early acute phase, the primary first responders are neutrophils. Watch how they roll, stick, and squeeze through. And once they cross that barrier, they don't just wander around aimlessly. They act exactly like bloodhounds, sniffing out a chemical scent trail called chemokines that leads them right to the geographic epicenter of the damage. Section 4, neutralizing the threat. The SWAT team has arrived, they've navigated the terrain, and now we enter the actual combat phase. The go-to weapon here is phagocytosis. The leukocytes literally act like Pac-Man, engulfing the enemy microbes. But eating them is just step 1. Once trapped inside a cellular chamber, the leukocyte unleashes this terrifying chemical arsenal. We are talking about reactive oxygen species, which is basically cellular bleach, along with nitric oxide and these highly destructive lysosomal enzymes. They chemically digest the microbes and totally clear away the wreckage. Okay, but this is perhaps the absolute most mind-blowing defense mechanism in our body's arsenal. When neutrophils get totally overwhelmed, they perform this heroic, sacrificial act. They literally spit out their own DNA to form these viscous, web-like structures called neutrophil extracellular traps, or nets. As you can see, a dying neutrophil throws this literal Spider-Man-style DNA web to physically trap and destroy bacteria right in their tracks so they can't spread. It is cellular martyrdom at its most brilliant. Section 5, acute versus chronic battles. The acute system is incredibly effective. But what happens when the alarm just won't shut off? It's really a tale of two completely different battles. Acute inflammation is that super fast response we just talked about, starring those quick strike neutrophils. It gets in, does the job, and resolves. But if the threat sticks around or the immune system glitches out, we shift into chronic inflammation. This is a prolonged siege. The body calls in the heavy artillery, macrophages and lymphocytes. And because this battle drags on for days, months, or even years, the massive weapons used against the microbes actually start inflicting severe, progressive collateral damage on your own healthy tissues.
You can actually see the sheer devastation of that prolonged siege right here in this lung tissue. Those delicate little air spaces you need for breathing, completely obliterated. The normal architecture has been totally wrecked by chronic inflammatory cells and paved over with thick, dense connective tissue, a process we call fibrosis. The battlefield basically just becomes one giant scar, which severely compromises the organ. Section 6, Resolution and Rebuilding. Let's look at the happier path, assuming the acute response does its job perfectly and the war is won. In this final cleanup phase, our macrophage sentinels put down their weapons and literally pick up their brooms. They sweep away the cellular debris, the dead neutrophils, all that extra fluid. Now, if the damage was mild, the tissue can fully regenerate back to normal. That's total resolution. But if the destruction was massive, the body takes that alternate path you see at the bottom. It patches over the cratered battleground with a connective tissue scar. You might lose some function, but it ensures your structural integrity holds up. As we wrap up this explainer, I want to leave you with this final provocative thought. We've just seen how incredibly complex, beautiful, and absolutely vital inflammation is for keeping us alive. It is a finely tuned survival machine. So, the very next time you reach for a bottle of pills just to quickly knock out the redness and swelling of a minor bump or scrape, ask yourself, are you actually helping